Okay, so this will be part 2, right? Factoring by grouping. And in the previous video, we factored things with 2 terms or 3 terms or 4 terms. But when you're factoring by grouping, you pretty much need an even number of terms. And almost always we're going to use 4 terms. Right? So when you have 2 terms, it's just GCF again. So here we're focusing on when we have 4 terms. Okay? So here's an example of that. Suppose we want to factor the following. Say we have x cubed minus 3x squared plus 2x minus 6. Okay. Now, the first thing you always look for, GCF. Can we factor out a GCF here? Well, there's no x in the last term, so we cannot factor out an x from all 4 terms. Right? And right, the 2 and the 6 have a factor of 2 in common, but there's no 2 in the first 2 terms. Right? So here, the GCF really is just 1. Okay? And when the GCF is 1, then you're stuck, right? Then there's nothing else you can do there, right? So after you either factor out the GCF, or if the GCF is 1, you move on to the next stage. The next stage is grouping. And remember, this is only when you have 4 terms, right? Or 6 or 8 or 10, but we're not going to see those. We're only going to see 4 terms in this class, right? And the reason why we need 4 terms is because we're going to divide this into 2 parts, right? We're going to split this up, the first 2 terms and the last 2 terms, right? So we're grouping together just the first 2 terms and just the last 2 terms separately. We're thinking of these as 2 separate problems now, right? So when you're factoring by grouping, you split it up, 2 terms each, right? And then you just factor out the GCF. Right. So let's start with x cubed minus 3x squared. So this is 1x cubed, right? So the GCF there is just 1, but they also have a common factor of x. So we can factor out an x. In fact, we can factor out the lowest exponent, which is 2. So we can factor out x squared. So by factoring out the x squared, when we divide, x cubed divided by x squared is just x. And then negative 3x squared divided by x squared is just negative 3. Okay? So, right, so that's the first 2 terms. We took care of that. Now we take care of the last 2 terms. So what's the GCF out of just the 2x and the negative 6? So the GCF there is just 2, say positive 2, right? 2x divided by 2 is x. Negative 6 divided by 2 is negative 3. Makes sense? So now look what we have. We have x squared times x minus 3 plus 2 times x minus 3. Right? So at this point, this should look familiar, right? This is something we did just in the last video. We have a common GCF of x minus 3. Even though it's 2 terms, that is the GCF, right? Which means we can factor out the x minus 3. And what does the x minus 3 multiply? Well, it multiplies the x squared and the plus 2. So x minus 3 times x squared plus 2. And that's as far as we can go, right? If you'd rather switch the order and write it as x squared plus 2 times x minus 3, that's okay too. Right? Order does not matter when you're multiplying. I mean, I'm sure you all know that, right? 3 times 5, 5 times 3, same thing. So same thing here. If you switch the order of the factors, right, you get the same thing. So let's try another one. Okay, so we want to factor by grouping 5xy minus 20y minus 8x plus 32. Okay, so again, we have 4 terms. That's how we know it's grouping. We have 1, 2, 3, 4 terms. So we know we can do grouping, or at least we can try to do grouping. We'll see if it works. Right, and sorry, factor by grouping, there should be a u in there, right? All right, so remember, we want to split this up into 2 separate problems, the first 2 terms and the last 2 terms, right? So out of the first 2 terms, what's the GCF? We have a common factor of 5 and a y, so we can factor out the 5y. And when we do that, we just get x minus 4. Make sense? Now we go on to the second 2 terms, the last 2 terms, these here. What's the GCF here? Well, 32, right, is divisible by 8, so the GCF is just 8. But remember, when you have a negative sign in front, this negative sign here, we're going to factor out a negative 8. And if we factor out a negative 8, negative 8x divided by negative 8 is positive x, and then 32 divided by negative 8 is negative 4. Makes sense? So now we see we have a common factor of x minus 4. So that's the next thing we want to factor out, x minus 4. What does it multiply? Multiplies the 5y and the negative 8. And that's it. Again, if you prefer 5y minus 8 times x minus 4, that's okay with me. Same thing. All right, try this one. Okay, so factor by grouping 4x cubed plus 10x squared plus 6x plus 15. Should be a plus here, right? So 4x cubed plus 10x squared plus 6x plus 15. Okay, let's see how you did. So 4x cubed plus 10x squared, and we're going to split that up, right? And then treat the 6x plus 15 later. So 4x cubed plus 10x squared. Well, we can factor out a 2 and an x squared. So the GCF is 2x squared, just from the first 2 terms, right? Don't worry about the last 2 terms. All right. So when you factor out the 2x squared, we get 2x plus 5, right? And then from the last 2 terms, we have 6x plus 15. So the GCF here is a 3. 6x divided by 3 is 2x, and 15 divided by 3 is 5, right? So we have 2x squared times 2x plus 5 plus 3 times 2x plus 5. Right? So at this point, it should be clear the 2x plus 5 is our common factor. It's our greatest common factor at this point. So we can factor out, to do that in yellow, the 2x plus 5, and that's going to multiply the 2x squared plus the 3. And we're done. Right? I don't know why you would have the 2x squared plus 3 first, and then the 2x plus 5 later, but that's okay too. Right? So, getting the hang of it, we'll try one more. Okay, so factor completely 3x to the 4 plus 15x cubed minus 6x squared minus 30x. Okay, so yeah, this is going to be a little tricky, right? Because it doesn't say factor by grouping. However, there are 4 terms, so you could split them up and just factor by grouping. However, remember, the first thing that you should do is find the GCF, right? We didn't do that in the previous problems because, well, we skipped it, right? But the GCF in the previous problem was 1 for all 4 terms. They have nothing in common other than the 1, right? Oops. And I think in the previous one also the GCF here was 1. So I kind of ignored that part, but it's kind of important because in this problem the GCF is not 1, right? These are all divisible by 3. 3, 15, 6, and 30 can all be divided by 3 evenly. So the GCF here is 3. And hang on, right? They all have an x in common. X to the 1 is the smallest exponent, but we can factor out the x as well. Okay, so yes, so the original problem, the GCF is 3x. So if we factor out the 3x first, what do we get? We get x cubed, right, plus 5x squared minus 2x, and then minus 15. Minus 10. Minus 10. Okay. Right. Now, are we done? Well, we did factor out the GCF, right? And to be fair, everything else here, the GCF would be 1. They have nothing else in common in these 4 terms. Right. Oops, went a little too far. However, there's still 4 terms, right? 1, 2, 3, 4 terms. So that tells me I might try factoring by grouping. So that's the next step, right? So I'm going to leave the 3x. That's part of the answer here, right? And then we have x cubed plus 5x squared. That's the first 2 terms. And then the minus 2x and the minus 10 are the last 2 terms. And remember, we split this up into 2 parts here, right? So forget the 3x. That's the GCF, the original GCF, right? Now, from these 2 terms here, what's the GCF out of those? Right? It's just x squared. So we can factor out an x squared. And when we divide x cubed by x squared, we get x. And 5x squared divided by x squared is just 5. Okay. Now, the last 2 terms. Factor out the GCF there. Right. So we have a negative 2 and a negative 10. They're both negative, but in particular, the first term is negative. So I'm going to factor out a negative 2. And that leaves us with x plus 5. Right? Yeah. If you don't factor out the negative, right? If you factor it out this way, if you factor out a positive 2, you're left with negative x minus 5. But that's not the same as x plus 5, right? They're opposites. So remember what I said, when you have a minus b, right, or b minus a, you can always factor out a negative sign. And so that's what we should have done here. We should have factored out a negative 2 instead of a positive 2. So you factor out a negative 2. I'll just erase the whole thing. Then you're multiplying a positive x times a positive 5. And let me just fix that. All right. Yep. So this is what we had before. Negative 2 times x plus 5, right? So now we can see our common factor, our GCF, is just the x plus 5. So we can factor that out. Ignore the 3x. We have a common factor of x plus 5. And what does it multiply? X squared minus 2. And now we're done. So yeah, this was essentially 2 steps here. We had to factor out the GCF first. That's the 3x. We factored that out. And then we looked at what's left over. This thing here has 4 terms. Whenever you see 4 terms, you should be thinking grouping. can I split them up, do the first two terms and the second two terms separately? Okay. Right. Now, let's say you didn't notice the GCF here, right? So I'm going to copy this down. This was the original problem. Right. And let's just say, okay, I didn't factor out the GCF because I didn't notice to do that. But I did factor by grouping, right? So I still split this up into two terms. What would happen there, right? So from the first two terms, you would factor out a 3x cubed, and you end up with x plus 5, right? From the last two terms, you can factor out a negative 6 and an x, and you end up with, again, x plus 5. Great, so we can factor out the x plus 5. And that multiplies 3x cubed minus 6x. So you can see the issue here. If you leave it like this, right, if you put this as your answer, you are not going to get full credit here. You're going to lose points. Remember what the answer was. It was this. Right, so this is correct. And you can see you don't have that. Right? So you're not done. Okay, so what do we do now? Now we look at this, right? Because here the x plus 5 is prime, but the 3x cubed minus 3x is not prime, right? This has a GCF of what? Well, a 3 and an x, right? So now we factor out the 3x, from just the second factor here. The x plus 5 is done. And now we factor out the 3x. And when we do that, we're left with x squared minus 2. Now we have the same thing as before. This is correct, although the 3x really belongs in front here. So put the 3x first, then the x plus 5, and then the x squared minus 2. And now it's the same answer as before, right? So, yeah, so if you don't factor out the GCF first, like we did over here, you're going to end up having to do it later over here. Okay? So, I mean, that's okay, but as a general rule, it's really better if you factor out the GCF as your first step here. Right? And then do the grouping as your second step. Right? It's a much better habit to do it that way than the second way here. Right? In particular, because, you know, if you're not careful, you might leave it like this, and then you'll lose points for not factoring completely. The problem did say factor completely, and we talked about that. You know, you can factor part of the way, right? Write 20 as, say, 4 times 5, but that's not factored completely because 4 is not prime. We have to factor 4 as 2 times 2. Right? Now it's factored completely because the 2 and the 5 are prime, right? So all these factors here are prime. Although, we don't know that yet about the x squared plus 2, but we'll see that later. Okay, so I hope this helps. I'll let you do one more grouping problem, and then we'll move on to the next section. Okay, factor completely. 8x cubed minus 12x squared plus 24x plus 36. Okay, well, again, in the last problem you learned, find the GCF first. Right? And it's not 1 here. Right? 8, 12, 24, and 36 are all certainly divisible by 2 because they're even numbers. But they're also divisible by 4, but nothing bigger than 4. Right? So 4 is the GCF. Erase these, yeah. And there's no x here, so we cannot factor out an x. right? Not from all 4 terms. So let's factor out the 4. And that leaves us with 2x cubed minus 3x squared plus 6x plus 9, right? Yep. So now we look for grouping, right? That's the second stage. Right? Because we have 4 terms here, right? We do the usual thing and split the first 2 and the last 2 separately. And let's see what happens. What can we factor out of the first 2 terms only? So 2x cubed minus 3x squared. All we can factor out is an x squared. And when we factor out x squared, we're left with 2x minus 3. Okay. What about the last 2 terms? The 6x plus 9. The 6 and the 9 are both divisible by 3. So 3 is the GCF. Let's factor out the 3. And 6x divided by 3 is 2x. And 9 divided by 3 is 3. Okay. So we factored the first 2 terms and the last 2 terms separately. Right. Now, we see that we can factor out the 2x minus 3. Well, hang on. These are not the same, are they? This is a plus 3, this is a minus 3. Okay, so maybe we might have more work to do, right? Are these opposites? The 2x minus 3 is not the same as 2x plus 3. I hope that's clear. But what's the opposite of 2x minus 3? If we factor out a negative 1, right, we get 3 minus 2x, or negative 2x plus 3. But you see the problem here. This is not a negative 2x. So these are not opposites, right? It's not a minus b and b minus a. Those are opposites, right? This is a minus b and a plus b. There's nothing we can do with these. Okay, this is something we'll see toward the end of the semester. These are called conjugates, not opposites. Okay, so when you have conjugates, there's really nothing you can do here. We cannot factor out a negative 1 because, well, right, 2x minus 3 and negative 2x plus 3 would be opposites, but not positive 2x plus 3. Right? It's only when they both have opposite signs, right? In other words, this is a positive a, this is a negative a, right? This is a negative b, this is a positive b. Those are opposites. But down here we have a positive a and a positive a, but a negative b and a positive b. So the b's are opposites, the a's have the same sign. That's what makes these conjugates rather than opposites. So what does that mean? It means we cannot factor by grouping. Right? In fact, we cannot we cannot factor any further. So we tried factoring by grouping, but it doesn't work here. These two things, these two terms here are not opposites. Right? I mean, you know, it's tricky because you have the negative and the plus, and we talked about that, but in order for this to work, this would have to be a negative 2x here instead of a positive 2x. Then we can factor out a negative sign. Here we cannot even factor out a negative sign. Right, so what's the answer? Well, the answer is, right, not that we can't factor it, but we just leave it like this. We did factor out the GCF, and as it turns out, that's all we can do here. We cannot go any further than that. So even though we tried factoring this by grouping, it didn't quite work out, and so we leave it alone. This is the final answer. You're only factoring out the GCF. You're not factoring by grouping because it doesn't work. Right? right? So if at this stage you end up with something like, let's say 4y times y plus 2, and then minus 3 times y plus 8. So at this stage, you know you're done. You know you cannot factor by grouping because y plus 2 and y plus 8 are not equal. They're not the same thing, right? And they're not opposites either, right? On the other hand, if you had, say, 4y times y plus 2, right, and then you had, let's say, negative 3 times negative y minus 2, right? If they're both plus and then these are both minus, now we can factor out the negative. Right? So I would leave the y plus 2 alone and then make this negative 3 times negative 1 times y plus 2. So effectively that changes this to a positive 3 now. Right? It's a negative times a negative. So that's a positive 3. But now we have the same factors. Y plus 2 is the same for both. So now we can factor out the y plus 2 times 4y plus 3. Okay. But again, that doesn't work when the two factors are different or when they just have different signs, right? So if one is y minus 2 and the other is y plus 2, same issue as here, right? They're not the same and they're not opposites. Okay, right. If they were opposites, you might see this. Right. If you have y minus 2 and 2 minus y, right, those are opposites. So what that means is we can change the sign in the second term here, make it a plus 3, and this would be y minus 2. Then you can factor out, the y, I'll do the y minus 2 first, times 4y plus 3. Oops, sorry about that. There we go, right? All right, so I hope this helps. Again, it's not often you're going to see tricky things like the opposite signs here, but in some problems you might. So I just want you to be aware of that, that in a couple of these problems could be tricky in the homework, but most of them won't. All right, so I guess I'll give you one more, and then we'll move on. Okay, factor completely 14p squared minus 70p plus 8p minus 40. Okay. So one thing I don't want you to do here is notice that these are like terms. And of course, you could add these first and get negative 62p. But that would turn it into a trinomial. And we're going to do that. We're going to do that next. Okay. So no, you can either factor by grouping first, although you should notice that all four numbers here are even numbers, so they're at least divisible by 2. And the question is, can we divide by, say, 4? And the answer is no. 14 and 70 are not divisible by 4. So the GCF here is just 2. So I would factor out the 2 first. You don't have to in this case, but it really does make it a little bit easier here. Okay, great. So now we split this into 2 and 2, right? Now we do grouping. Right. So again, ignore the 2 on the outside. That's the GCF. We're done with that. But from the first 2 terms here, we can factor out both a 7 and a p. So when you divide by 7p, you just get p minus 5. From the last 2 terms, you can factor out a 4. divide by 4, you get p minus 5, right? And there we go. P minus 5 and p minus 5 are identical. They're exactly the same. There's no opposites. There's nothing tricky going on here. So when you factor out the p minus 5, you end up with 2 times p minus 5 times 7p plus the 4. So 7p plus 4. And now we're done. And just to remind you that if you put the 7p plus 4 in front of the p minus 5, yeah, same thing. All right. So I hope this helps. This should give you enough, well, it should give you enough information to be able to do the homework and the quizzes. Right? Most of them are not going to be any trickier than this. Right? Again, the thing you have to watch out for is, say p minus 5 and 5 minus p, because those are opposites. Oops, p minus 5 now. Right? Right. And in general, that's, a minus b and b minus a. Those are opposites, so you can just factor out a negative 1. Right? And if they're both negative, say negative a minus b, you factor out a negative 1, you get a plus b. Okay, so we've seen that too, but not quite as often. It's less tricky, I think, when they're both negative or both positive. All right, best of luck.